Hi, I'm Cheryl Leach. In this video, we're going to be looking at a process called implicit differentiation. Let's start with an equation. We're going to be looking at y squared equals 1 minus x squared when x is between 0 and 1. Now, I want to find the derivative, and in this case, I want to find dy dx. But this is different than any problem that we've had so far because my equation is not solved for y. So how do I handle that? Well, one option is to solve this equation for y. Let's see what happens. When I solve for y, I need to take the square root of both sides. But recall that when you take the square root of both sides of an equation, your result is going to be plus or minus the square root of 1 minus x squared. I also want to point out at this juncture that my first statement required x to be between 0 and 1. Right? That was important because in this problem, x really could be anything. When I write it in this format, it becomes clear why x has to be between 0 and 1. If x is not between 0 and 1, we'll have a negative under our radical sign, which is a complex number, and that's not something we're going to be dealing with. So now I'm ready to find the derivative because my equation is solved for y. One more thing I might do here is use fractional exponents instead of that radical notation. We've done that before. So I have plus or minus the quantity 1 minus x squared to the 1/2 power. Okay. So I'm ready to take my derivative. The only thing that's a little unusual here is that plus or minus in front, but that's just a plus or minus 1. You can treat it like a constant multiple. So dy dx, we'll start with the constant multiple rule and we'll pull out that plus or minus 1. And now I can take the derivative of 1 minus x squared to the 1/2 power. So it's a general power rule. We'll bring down the 1/2, copy over 1 minus x squared, subtract 1 from the exponent. And then by the chain rule, multiply by the derivative of the inside piece, which is going to be a negative 2x. Okay? It's time to simplify. I notice that this 2 will cancel with that one. And this entire quantity that's raised to the minus 1/2, I can put that in the denominator. And I'm going to write it with the root. So the square root of 1 minus x squared. This minus x is going to remain in the numerator, but I'm going to be multiplying it by a plus or a minus 1. Well, when you multiply plus or minus 1 by negative 1, you just get negative or positive 1. And so we have a negative or positive x divided by the square root of 1 minus x squared. Now we know that the derivative is the slope of a tangent line, so it's a little strange maybe that I have a plus or minus. Well, it's not really. Let's take a look at my graph. When I graph my original equation, I get a circle. But this stipulation that says that x has to be between 0 and 1 means I'm really only looking at this right-hand half of my circle. So what happens at any given point? Let's say x is this value. Let's find the tangent line. Well, that's the tangent line at that value of x. I'll mark that as an x. And so is that. I have two different answers, which is why I had the minus or plus version. Well, this was actually fairly complicated. And I told you at the beginning that we were going to be talking about a technique called implicit differentiation. Implicit differentiation gives me an alternative when solving for y is either difficult or, in some cases, not even possible. So let's rework this problem using implicit differentiation. So I'm going to start with y squared equals 1 minus x squared. And again, x is going to go between 0 and 1. This time, I'm not going to worry about solving for y. I'm just going to differentiate. Now, in the last example, I differentiated both sides of my equation. The same is true for implicit differentiation. You differentiate both sides. So I'm going to begin by differentiating y squared. That's going to be the power rule. So I'm going to bring down the 2, copy over the y, and subtract 1 from the exponent. But there's a chain rule involved here as well, because the derivative of y with respect to x is not 1, it is dy dx. Just like the derivative of y in this example was dy dx. So I've now completed the derivative of the left-hand side of that equation. Now I need to take the derivative on the right-hand side. On the right-hand side, my main operation is a subtraction problem, so I'm going to differentiate each piece. The derivative of 1 is 0, and the derivative of x squared with respect to x is 2x. Again, if you want to think of the chain rule, you can, but the derivative of x with respect to x is 1. So now I can solve for dy dx by simply dividing both sides by 2y. So let's do a little cleanup first. We'll say 2y times dy dx is minus 2x, and so dy dx is going to be minus 2x all over 2y. The 2's cancel, and I'm left with a minus x all over y. Now, my derivative has y's in it, and that's a little different, but that's okay. Let's see, is it really the same thing that I had before? Well, if I were to solve my equation for y, what would it be? Plus or minus the square root of 1 minus x squared, and then my 2 samples would be exactly the same. Looking back at our picture, in this version, you're going to need to know what both the x and the y are. So if you know what both the x and the y are, for this input x, you're going to know which of these points you're going to be looking at. So you'll either be looking at a possibility where x is positive and y is positive, or the possibility where x is positive and y is negative. And in either case, you'll get the slope of the tangent lines. I hope this was helpful. Thanks.